As I mentioned earlier, we're going to be spending a couple days today and tomorrow reviewing some of the basic concepts in Java and object-oriented design and development. Some of this you might already be familiar with, and we're just going to start from there, from what you might already know, all the skills of using object-oriented programming in general, and we're going to apply some of the design principles that we've been presenting for the last couple of days. We're going to take a really trivial example. We'll apply some design principles and see how that might make the implementation better. Okay, and it'll give us a chance to review some of the Java skills. Right. So we're going to apply some of the design principles that we've been looking at for the last couple of days. We'll first start with an interface. All right, as opposed to focusing on any particular implementation. First, we'll sit down, we'll look at what is a requirements, right? We'll try to see what the actual scope of the problem is, try to understand what the use cases are, who's using this, what is it that they are trying to do with it, what are their goals, and from those use cases, what is, presumably we know who might want to use this, that will drive the rest of the design, right? Usually it always starts with somebody who needs to fulfill or accomplish some goal, and that goal then drives everything else, right? We don't just build and create things out of the blue and for the love of art. We build something because somebody has a need for it, right? We'll first try to capture that a solution in terms of an interface, a very generic, very abstract solution, and then look at a couple of alternative implementations. We'll look at one particular implementation first in much detail, and then revisit it and say, well, what could have gone better, okay? And what were the design decisions that we decide to go one way or another, and how it would be better one way or another, and then compare them and try to see if we can extract some principles that can then be used in general. A lot of all these techniques are with the intent of dealing with complexity, reducing any code that has been could be duplicated multiple times. A good developer is a lazy developer, right? If you see yourself copying and pasting or writing the same thing twice, that immediately should be a flag to you that perhaps you're doing something wrong, right? Can I generalize this, right? If I see myself writing and copying code from here and there, perhaps that's immediately should wake you up and says, okay, well, can I abstract this? Can I put it at a higher level that can then be reused elsewhere? Instead of right. So we first try to identify what the algorithm might be, and we try to box it in and parameterize it so that we can be used generically. So we're looking at abstraction as a means for minimizing any replication, any code replication that we might have. And we'll take a look at alternative implementations, look at principles, and see what advantages are by applying those principles. So let's look at a really trivial example and say we want to model the concept of duration, right? Of things lasting for minutes, seconds, days, years, months. So let's look at something as trivial as that, right? So before we go in and start coding, whether this is long and be able to constructors and whatnot, let's first step back and say, well, who's using this? What is it that they're trying to achieve? Right? What are the types of operations that they might use? And it depends, right? If you're trying to write a library that does duration, depends who your client is, right? If you don't know who your client is, typically your interface will be very, very generic. Right, trying to be very, very broad to appeal to the broadest number of folks who might be using your library. Or if it's something that is in-house, very, very focused, that it has a very vertical application, then your interface will be very, very narrow, right? And it'll only implement those operations that are very specific to your vertical solution. Make sense? right? So that's why if you buy a library out there, maybe a gaming library or animation library, they don't know who's going to, what kind of game you're going to be building. So their interfaces tend to be very, very broad, right? And they have lots of syntactic sugar versions of the same function, depending on what is it, how you want to call it, right? So they'll have a very, very broad. If instead of something in-house, again, it'll be very, very narrow and specific to your needs. So let's look at whoever might want to use this library. What is it that they might want to represent? Are there something that they're trying to measure, microseconds or years or minutes? Do they want to be able to represent this in all sorts of formats? Do you want to represent it in military format, in U.S. format, in European format? Do you want to use a Gregorian calendar? Do you want to use a lunar calendar, solar calendars? What is it that you want to look at this, right? Who's using this? The scope could be huge or it could be very narrow. Yes. So we need to decide what is the scope of this, right? It could get very, very wielding and untractable. It could be very trivial. So what do we mean by duration? What kind of operations? Who's using this? So out of a plethora of things that we could possibly consider, we might narrow down into a couple things that might be of interest to us, right? Perhaps after meeting with our clients and seeing who actually is using this, we might decide that it's not, you don't want the universe, you want something that is fairly narrow, right? And it's not, I don't have months to work on this. It might be that it's due on Friday. So we might decide on says, okay, well, with the resources of time and effort and money and finances behind this, this is all I can give you, right? I want to be able to convert between units, right? Between minutes and seconds, and even though they might have two different representations, they should be logically the same, right? So if you say an hour and a half, it should be equivalent to say 90 minutes, yes? Even though there might be different ways to represent them. They have different formats, in seconds or printed as minutes or in minutes and seconds, and different ways to format this. You might want to do all sorts of mathematical operations of being able to add hours, minutes, seconds, months, weeks, and the library should be smart enough to know what is the equivalence, right, between all these different ways to represent them. You want to be able to add, you want to be able to subtract 5 hours and 2 minutes from 3 hours. Also, we might decide on a subset of human-friendly representations, maybe based on some locale, whether you're in Western Hemisphere, Eastern, Middle East, or Far East. So depending on, we'll settle on saying, well, we're going to center on just being able to represent them in hours, minutes, and seconds. We'll settle on that particular human-friendly. Seems that it's pretty standard across the world. I also want to be able to compare durations, maybe because I want to be able to sort by the duration, right? Maybe I want to be able to filter. I want to do pagination over things that are long collections of durations, and I would be able to sort them or just compare them, right? Equality and order. So yeah, so this might be a subset of things we might agree as part of the scope when we meet with our clients who's going to be using this. And so let's first just settle on implementing just even a narrower feature, and the assignment might ask you to go further and implement a couple more features. But let's for purposes of this lecture, let's just focus on being able to do conversion. Right, we'll settle on the smallest, what we mean to be the smallest unit of time. We'll settle that, we'll just say that it's the integers, right? For the second, I'm not going to go into milliseconds or microseconds or anything like that, right? So we'll decide the level of accuracy that we want to work with, again, based on who's going to be using this, right? Who's going to be using my library. Maybe seconds is not enough. Somebody needs milliseconds or microseconds, right? Depending on their particular needs. But let's agree on seconds. Also, we'll deal with only positive numbers. We'll settle on one particular formatting, addition, and comparison. Just these 4 things, right? Right. So as I mentioned earlier, based on the use cases, based on having met with our who's going to be using this, we'll identify what are their purposes, how are they going to be using this, and that's going to drive the rest of our design. And this is a principle that applies to software engineering in general, right? That oftentimes you're coding not in a vacuum. You're coding because somebody has a business plan and wants to make some product out of it, and we are just a cog in this bigger machine, and we want to identify what are the use cases, what is the client who's using this. So we're going to try and define what some of the assumptions are. Like, for instance, the resolution will settle on what is the smallest, what is the base representation of time or duration. Will settle on seconds, right? An integer representing seconds. So are there any bounds, right? Is there a biggest duration that we can decide? Or is it years, decades, thousands of years? Is there a upper boundary that we can decide on? Is there a lower boundary, right? Is it zero? Are there negative numbers? Are we going to throw that away? How is it that we're going to be able to easily be able to determine that that 1 minute is 60 seconds, that 60 minutes is 1 hour, and how do we do the conversion between all these different disparate ways of representing the same amount of time? So we'll settle on the smallest units being the integer second, no negatives. We won't decide on a maximum yet. Instead, we're going to leave that open and to be dealt by a particular implementation, right? Depending how you're implementing this, whether you're using integers, longs, doubles, floats, however you want to use to actually represent this data. That will be the limitation on what the maximum amount of duration you can represent. So we're going to leave that open, right? And we'll kick the can down the line, and have each way that you represent it decide what the maximum value of the duration is. We'll at the highest level we'll decide that the pure lengths of time are going to be seconds, right? We're going to represent everything else, minutes, hours, everything down to seconds, right? So that we can easily do additions and multiplications and subtraction and do the conversions it'll make it so much easier to represent it in the smallest unit. All right, so having made some of these assumptions, we can get started on our design, our implementation, right? And the best practice typically is to get started at the highest level of abstraction, right? And capture the concept of duration as an interface, right? And then let specific implementations decide how to implement this interface, right? And we'll see some of the benefits on deciding how when to use an implementation, when to use an interface, right? And hopefully we'll come to an agreement that most of the times we'll want to settle on the most generic representation of the idea or the concept of duration. So here's a duration. As long as we stick to implementing everything else in terms of this interface, it will let us very easily change the implementation and switch between implementations without disturbing everybody else. Right? The idea would be that whoever's using this duration, instead of writing their code in terms of any specific implementation, they will write their code in terms of this generic interface. If they do that, right, we're free to change the implementation any which way we want, right? And the clients will be completely oblivious, right, of any changes that we might be doing underneath, right? One particular example of this is, for instance, the Java database connectivity interface, right? The Java database connectivity interface, Jdbc. Anybody play around with Jdbc? No? Okay. All right. You have? Okay. So the idea behind Java, right? What Java tries to do is what? The whole mantra of Java is code once, run anywhere, right? So Java is an example, right, of creating these interfaces, these abstraction layers, so that you're not tied down to any one particular implementation, right? You code towards Java, without caring whether the underlying machine is a Windows machine or a Mac OS machine. It doesn't matter, right? They create this interface layer so that if you code to this interface layer, you don't really care what it compiles down to the native representation. Make sense? Right? This allows your code to very easily be transported across multiple vendors. Right? Same thing. They apply the same idea to database access. Right? They say, well, there's always the issue that if you're coding your database access to MySQL, you have to use this interface. If you're coding now your code to Oracle, then you have to change your implementation. If you code to SQL Server, then you have to change it again. So changing between vendors has been a headache. So they created this interface in between, right, called the Jdbc interface. And as long as you code to this interface of connections, statements, result sets, right, as long as you stay at the interface level, right, you can very easily swap one vendor for another vendor. Right? You can very easily swap MySQL Server for Oracle to SQL Server, right? And your code is completely oblivious of what actual database you're using underneath. Pretty cool, right? And the idea is that all these vendors create all these implementations by implementing the Jdbc interface. And as long as you stay with the interface, you're oblivious to the implementation underneath. Very cool. So we want to achieve the same kind of decoupling, right? We want to have our code also be decoupled from the actual implementation, right? So our idea would be to write all our code in terms of interfaces, right, and not be tied down to any one particular implementation. Make sense? Right? All right, so here's a very trivial example where we have an interface, and ideally our clients, whoever's using our code, they would be writing all their implementations in terms of this interface as opposed to any one particular implementation. So here's the interface called the duration interface. Notice that the duration interface, we are extending comparable. Right? Comparable is a library, is a Java package that allows you to compare any two things. Right? You need to tell it how to compare it. You need to tell it, well, you compare time by comparing the hours and minutes and seconds, and you say, well, if these are greater than this other set of hours, minutes, and seconds, then this is bigger and that's smaller. Right? You need to tell it. But what this interface allows you to do is that allows you to implement a specific compare or equals function, right? That allows you to tell it. That allows you to be able to compare two durations, right? And we need to tell it how to. Right? It doesn't know how to compare my durations. We need to tell it how to compare. But this is how it's used, right? You extend the comparable interface, right? And you tell it what is it that you're comparing. You're comparing duration. Right? So we'll see how to implement that in a minute. But yeah, so we are inheriting, right? All those functions, actually just one function, so that we can then participate and be able to compare one duration versus another duration, whether one is bigger, equal, or less than another duration. Then we decided as part of the design and some of the assumptions is that we will try to canonize or create a canonical representation of time or duration in terms of seconds. Right? That's going to be our baseline. So we always want to be able to convert and see what the representation is in terms of seconds. Right? So here's a function, right, that returns the number of seconds that this particular duration represents. And yeah, so whatever implementation we decide on, right, whether we're going to represent it as minutes, hours, and seconds, or whatever other representation, they will need to be able to convert whatever implementation they have. Always they have to be able to tell us, whatever your representation is, what does it look like in seconds, right? So I can return it to some canonical interpretation of this duration. The other is again based on the requirements that we looked at earlier. We want to what's the difference between a long and an int? Long allows you to create the range is just much bigger. Right? So much more bytes. Right? Yeah, so we also had assumed that we're going to represent the however we implement it, using lunar calendar, Gregorian calendar, solar, or whatever calendar we decide to use to represent durations. We always need to be able to represent it in some human readable format, right? Whatever the implementation is, right? And so we're going to declare a function here that allows us to convert whatever implementation is into some human readable format. Okay. Right. And presumably we will convert it to decide on this particular pattern of hours, minutes, and seconds. Also, we had according to the requirements that we had agreed on, we'll implement at least one arithmetic operator that knows how to add one duration added to some other duration, right? Typically, it would be adding the current duration that we're in, the current instance of duration that we're in, adding it to some duration that you pass as an argument, right? And then return a brand new duration that is the addition of these two. Most commonly, the ways to add it will be probably to convert everything back into seconds, right? And once it's converted into seconds, then do the arithmetic and then return the equivalent of that particular implementation in seconds, right? But again, it depends on how do you implement it, right? You might be implementing so many sols, so many lunas, how many months, weeks, or fortnights, or how is it that you represented your particular implementation, right? Other things. Notice that we're passing along. Right. Notice that we're passing along in the plus. Notice that we're passing along a reference to our interface. Right. So it doesn't depend on any one particular implementation. Right. We're passing that we should be able to add one duration to another duration, regardless of how it's implemented internally. Right. And this is the principle of dependency inversion that allows us to not depend on any one particular implementation. Also, notice that we've been using this Java docs everywhere. This @param and @return that allows us to configure or document these methods, the interface themselves, right? The first sentence here, returns the sum of two durations. All those sentences at the beginning of methods, at the beginning of classes, the Java doc grabs those sentences, right? It creates a website, right? It creates a table of content at the top of the web page for your particular interface, right? So that it should be a very succinct sentence or paragraph, right? That kind of is the statement of purpose of this interface, or the statement of purpose for your method or function. Okay. So it should be a very succinct, to the point, describing the purpose of this function or the purpose of the interface. Also, you can configure the parameters that you're passing along, right? Whoever's using this, the client of our interface, what is it that should expect what is it that the method is expecting to be passed along, right? Also, you can configure and describe what the resulting value that comes back from this method, such as using the annotation of @return. You can intersperse also some code so that it's formatted in single characters. What is that looks like code, right? Like using Courier fonts. Yeah, so use Java docs for in your code, right? It's a good practice. All right, so let's take a look at some ideas on how we can implement this.